So we're going to talk about finding the derivative of an exponential function. We're just talking about the really most basic function of them all, f of x equals e to the x. The basic derivative rule right here, and I will not develop in this video, is that when you take the derivative of e to the x, it is the kind of function that is its own derivative. In other words, e to the x is one of the few functions out there that has this property that a rate of change of e to the x is equal to itself, e to the x. The derivative, if we forward this rule a little bit further here, of e to the u, if we have some function as that exponent, this rule tells us, well, the derivative will also be e to the u multiplied by the derivative of u itself. So let's take a look at a couple of functions right here and just show this rule in action. In the first example, we want to try to find the derivative of f of x equals 2 times e to the 3x plus 2. So this is a case of this rule right here. We're taking e raised to an exponent that we can take a derivative of itself. It's a function of x. So going down the row right here, we're going to take the derivative with respect to x of 2 times e to the 3x plus 2 power. First of all, by the constant multiple rule, that factor of 2 can be pulled out, and we're just going to be taking the derivative of e to the 3x plus 2 power. Well, its derivative, by this rule, is going to be equal to 2 times e raised to the 3x plus 2 times the derivative of 3x plus 2. Well, we know that that derivative is going to be 3, so we're going to have 2 times e to the 3x plus 2 power times 3. Or simply stated, our derivative, f prime of x, is going to be 6 times e to the 3x plus 2. All right, how about this next one? We've got y equals e to the square root of x. How would we find its derivative? Well, if we're looking for a dy dx right here, this is again an example of that e to the x chain rule here that states that if we take the derivative of e to the square root of x, what we should really be looking for is e to the square root of x times the derivative with respect to x of the square root of x. Well, the square root of x, don't forget, that's x to the 1/2 power. So we've got e to the square root of x times the derivative with respect to x of x to the 1/2 power. And using our exponent rule here, our power rule here for derivatives, we're going to take e to the square root of x and multiply that by 1/2 times e to the negative 1/2 power. Or sorry, x to the negative 1/2 power. Boy, I have those e's floating around. I'm going to confuse myself. Let's try that again. X to the negative 1/2 power. All right. So if we simplify this expression, what should we expect to see? In this case, e to the square root of x will be divided by 2 times x to the 1/2, but that's the square root of x. And so our derivative, I'm going to change notation, I'm going to write it as y prime right here. The derivative of y prime, is equal to e to the square root of x over 2 times the square root of x, which fits with our rule right up here. Okay, more to come.